Evaluate these expressions. What we're going to do today is expand this, our understanding or knowledge of the trig functions. So we have sine of 3 pi over 4. We know that the reference angle here is pi over 4. Sine of pi over 4 is square root of 2 over 2. And then we say 3 pi over 4 is in the second quadrant. And in the second quadrant, sine is positive. So this is positive root 2 over 2. Very similar here, but now we have a fraction, 1 over 240. So we're going to say 1 over sine of 240 has a reference angle of 60 degrees. So the sine of 60 degrees is square root of 3 over 2. 240 is in the third quadrant, so it's a negative. And we will flip and multiply, so we'll have negative 2 over square root of 3. And we rationalize that to get negative 2 root 3 over 3. Similarly, we have 1 over tangent. Now, we can do this several different ways. We could say that this is 1 over the sine of 5 pi over 6 divided by the cosine of 5 pi over 6. Notice that the angle goes with both the sine and the cosine. So we have sine of 5 pi over 6 over cosine 5 pi over 6. And that is we can flip and multiply again. We have a cosine of 5 pi over 6 divided by the sine of 5 pi over 6. We're dividing by this fraction, so we flip and multiply by cosine over sine. And we get this. Now we got to say what's the cosine of 5 pi over 6? Has a reference angle of pi over 6. So it's square root of 3 over 2 over 1/2. It is in the second quadrant. The x value is negative. The y value is positive. So this simplifies to negative square root of 3. The next one, find the reference angle. This should be pretty straightforward at this point. We can take a quick look. We're going to go to 285 degrees. That's going to put us past 270, so we're in the fourth quadrant. So our reference angle here will be 360 minus 285, and that would be 75. So we say sine of 75, and now we determine are they the same or opposite. In the fourth quadrant, sine is negative, so we put negative sine of 75 degrees. Cosine 2, it just says 2. So what is the unit of measure there? It's a radian. So remember, we have, for looking at a unit circle, or any circle, a radian is the radius mapped onto the circle. So we have 1, 2. That puts us in the second quadrant. Our reference angle is going to be pi minus 2. So we'll say cosine of pi minus 2. And what is cosine in the second quadrant? It's negative. Remember in the first quadrant, this angle here, even though it looks ugly, is going to put us in the first quadrant. It's going to be something less than pi over 2 or 90 degrees. Okay, that's all for that review. And then we're going to start defining some new things here. If I give you this angle, here's theta, we have r, and we have some point x comma y. You can write, here's a definition. The sine of theta, we already know in a unit circle would just be the y value. And when we have a radius that's not 1, a simple way to see it, and I'll draw this, although it applies always if it was in the first quadrant, and this is theta and r, and there's y and x, we could say sine is opposite over hypotenuse, and that's what it is always. Cosine would be the adjacent, and we can deal with the reference angle, and as long as we take into account if it's positive or negative, these always work. And then the tangent is opposite adjacent. And on this case, x cannot equal 0. Now we already know as well that this can be written as the sine of theta over the cosine of theta. Now I'm going to do this just a little differently. Cosecant is 1 over the sine of theta. and that's going to be r. So in other words, the reciprocal of sine, so it's going to be r over y. And over here, y cannot be 0. Secant is going to be 1 over the cosine of theta, so that will be r over x, and x cannot equal 0. And then cotangent can be written as 1 over tangent theta, which is the same thing as the reciprocal of tan, or cosine of theta, over the sine of theta. And in terms of our letters, it could be written as x over y, and here y cannot be 0. So all the trig functions can be related back to our sine and cosine. And at this point, we're going to just apply these same ideas that we know to these new trig functions. 290 degrees. We're going to go around. We go past 270. We find our reference angle, 360 minus 290, and that gives us 70 degrees. So we'll write cotangent, just rewrite the trig function, 70 degrees. Now we look. In the fourth quadrant, what is cotangent? Well, cotangent is cosine over sine, or x over y. The cosine value, x, is positive, and the sine value, the y, is negative. So a positive divided by a negative is negative. So we'll just put negative here. Secant of negative 105 degrees. So we go negative 90, something past there. Our reference angle this time will be 180 minus 105, so we'll get 75. So we'll write secant 75 degrees. In the third quadrant, secant's 1 over cosine. In the third quadrant, cosine is negative, so secant is negative. Wherever cosine's negative or positive, those are the same places that secant will be negative or positive. Cosecant 600 degrees. Well, you can see that that's going to be more than 360. How much more? We got to keep on going. We can subtract 360 from there, and we'll get 240. So that's going to put us in the third quadrant. A coterminal angle is 240, so our reference angle would be 240 minus 180, or 60 degrees. So we will write cosecant 60 degrees. Now, in the third quadrant, what is cosecant? Well, cosecant is 1 over sine. In the third quadrant, sine is negative. So 1 over a negative is negative. And the last one, tangent, as far as these problems go. What's the unit of measure again? Yes, it's radians. So we're going to come over here. When do I stop? We know half a circle is pi, which is a number, 3.14. So we have something like this. And what's that angle? That reference angle is just pi minus 3. That's the exact value. I want you to use that instead of some approximation. And we have tangent of pi over 3. Now we have to determine, is tangent positive or negative in the second quadrant? Well, tangent is sine over cosine. Sine is our y value. The y value is positive. The cosine is our x value is negative. A positive divided by a negative is negative. And so really, there's no significant difference for doing those things. You just have to remember which ones go with which. Here's one way to take a look at this. If you look at the first letter, some people like this, so I'll point it out. The first letter of each of these, the hardest one, cotangent, is pretty straightforward. Most people know, okay, that's going to go with tangent. But people will get the cosecant and secant mixed up. If you look at a C goes with S and S goes with C, so there's no way a C can go with a C. Cosecant cannot go with cosine. Cosecant always goes with sine. It's a reciprocal of sine. And secant goes with cosine. The S goes with the C goes with the S. Now let's graph y equals secant. And we realize that this is the same as 1 over cosine of x. So what we're going to first do is we're going to start by graphing. Let's graph y equals cosine x. We'll mark our key numbers here. Whenever you're graphing, you're going to always label 5 key points. Pi over 2, pi, 3 pi over 2, 2 pi. And then we'll go, for right now, in the opposite direction. Since you know the basic shape of the cosine graph and the sine graph, all we need to do is get a few points down there, and then we'll be fine. So the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. 3 pi cosine is 0. And then cosine of 2 pi is 1 again. Cosine of negative pi over 2 is 0. Cosine of negative pi is negative 1. Now note here, what's happening is always going to happen. It's going to be the same. We go high, mid, low, mid, high. Let's sketch it with a dotted curve, because our focus here is not the cosine, it's secant. Now let's use this to figure out the secant graph. Now what are our key values here? Well, we're looking at the reciprocal. 1 over 1 is 1. So all of these points where it's 1 are going to be the same, and 1 over negative 1 is negative 1, and those are going to be the same. What's 1 over 0? 1 over 0 is undefined. So what we're going to do is have an asymptote here. So all these 0 values, let's put an asymptote down. And that's going to help us to, these questions here are key values. Where are these? This is pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, etc. What's the difference between each one of those? It is, we can start with the pi over 2. If we add pi, we get this next one. If we add pi again, we'll get 5 pi over 2. So it's pi over 2 plus pi n. Now we have the reciprocal 1 over 1. Where does it equal 1? It's going to be at 0, at 2 pi, at negative 2 pi. These values will be at 0 plus 2 pi n. Where will it be negative 1? It'll be at negative pi, pi, 3 pi, 5 pi. So that will be pi plus 2 pi n. We keep on going one full turn around the circle. And let's hold off on the 0 part. Now, 1 over 1 is 1. Let's just pick some random numbers in here where it's a half. Okay, what's 1 over a half? That would be up here at 2. What's happening to these values here? They're getting smaller. 1 over a fourth, what's that going to be? 4. I'm not doing this to scale. 1 over 10 will shoot up to 10. What's 1 over 100? You go up to 100. So what's happening to these values here? They're getting bigger and bigger and bigger and bigger. What's the difference between this side? Well, there is none. These are positive values. 1 over a half is still going to be 2. 1 over a fourth is still going to be 4. 1 over 10 is still going to be 10. And so it looks something like that. Similarly, we now have between pi over 2 and 3 pi over 2, what's the difference? These are all negatives. So if we have negative 1/2, the reciprocal will be negative 2. So they're getting smaller. And then once we have this basic shape, we can, all these sections will look basically alike. Now, some people like to think of this as parabolas. Are they parabolas? No, they're not really parabolas because they have these asymptotes, and parabolas don't have asymptotes. All right. you can also do, if I did cosecant, you would start off with the sine graph, and then it would look very similar. Where does secant equal 0? Where does this solid graph touch the x-axis? Never. At no place can you find the reciprocal and have it equal 0. All right, the next one. Tangent equals -3/4. We're going to set up an xy axis. We're told that we're between pi over 2 and 3 pi over 2. So here's pi over 2, and then we'll go to 3 pi over 2, so we don't want any of this section. Where is tangent negative? In the second or the third quadrant? Well, it's going to be in the second quadrant because sine's positive and cosine's negative. Now, we need to determine, we have this negative here. Where does the negative go? Does it go with the 3 or does it go with the 4? Well, since this vertical value here is positive, that 3 has to be positive. The x value here is negative. The 4 has to go with, the negative has to go with the 4. Use the Pythagorean theorem. You already know this is 5. So now we can say the sine of theta equals 3 over 5. The cosine of theta equals -4 over 5. So the key thing here is you need to be careful about that negative. Look what quadrant you're in, and you have to give the negative to the appropriate number. Number 12, given sine x equals 7/25, and we're told that x is in between pi over 2 and 3 pi over 2. So we're going to sketch this. Pi over 2 to 3 pi over 2, that means we're going to be using the second or third quadrant. We're told sine is positive. So what quadrant are we in? We're in the second quadrant because sine would be negative. Sine's our y value. Sine is opposite 7 over hypotenuse 25. Now technically, this angle here is x. But as long as we take into account the positive or negative of the lengths, that's either the horizontal or the vertical, your radius, your hypotenuse will not ever be negative for anything that we're going to do. So as long as we take into account positive and negative, we're perfectly fine. So what we want to do is we'll call this about a. So a squared plus 7 squared equals 25 squared. Does anybody know what this answer is without thinking? This is another common one. So we have 625 minus 49, and we get 576. And the square root of 576. Now technically we have plus or minus, but do we include both of them? No, we can only include one of them. And the question becomes, which one? Square root of 576 is 24. Is it the positive or negative? Well, you have to look and see what quadrant are you in. We're in the second quadrant, so A is negative. So now we can say cosine is adjacent, -24 over 25. Secant would be the reciprocal of that, or hypotenuse over adjacent, so -25 over 24. I do not want to see you put 25 over -24. That negative goes out in the front or to the top. Cosecant's 1 over sine. Sine's opposite over hypotenuse, so it's hypotenuse over opposite. Tangent, opposite over adjacent. So 7 over 24, and it is a negative. And cotangent would be adjacent over hypotenuse. So now we've done 2 of these, and we'll do look at one last one. After this, they're all basically the same. Cosecant, x equals -2. So we set this up. What quadrant? Again, we're in the either second or third. It's a negative. And cosecant's 1 over sine, so we must be in the third quadrant. The cosecant 1 over sine. Sine is opposite over hypotenuse, so this will be hypotenuse over opposite. Now, I told you in the previous one, the hypotenuse is not negative, so this will be 2, because this can be written 2 over -1. So the opposite will be the -1. We can use our Pythagorean theorem if you don't know what the answer is right away, and we can call it A again. So a squared plus 1 equals 4, a squared equals 3, a equals plus or minus square root of 3. Which one do we want? We're in the third quadrant. The a value, the x value is negative, so it has to be negative square root of 3. So then cosine would be negative square root of 3 over 2. And cotangent would be adjacent over opposite. So it'd be negative root 3 over negative 1, or in other words, just square root of 3. Now my question for you is, what is x? Do you recognize that based on these numbers? Notice it's 1, 2, root 3 triangle. So the inside part of the triangle here must be what angle? Opposite the small side would be the small angle, so that would be 30 degrees. We add 30 to 180, which is the horizontal line. So what is x? X is 210 degrees, so write that down. And with that, I am done with these notes. You can notice that there was another page for day 2. If you look at that first problem, really it's the same basic thing as 11, 12, 13. You need to know these problems 11, 12, 13. Then when we get to those next sections and whatnot, you need to be able to refer back to these because the process is the same. The only thing that changes is which function you're given and which one you're trying to find. And then as far as the next problem 2, those are more practice for your unit circle.